Welcome to lecture 7, which is on photographic sensors in drone. In this lecture, you are going to learn various kinds of photographic sensors which are used in the drone system for mapping, their function and use of photogrammetric sensor and their various applications. If we look back the developments in photogrammetry, in 1883, Douglas Archibald, an Englishman, attached an anemometer to the line of the kite. So, photographs were taken at an altitude of 1200 feet, and these photographs were taken with the help of the kite. So, this was one of the world's first reconnaissance drone system or UAV system. Then William Eddy took hundreds of photographs from the kites during the Spanish-American War, and which may have been one of the first uses of the drone in combat. And later on, this technology has developed a lot. If we look at the developments in photogrammetry from around 1900, there are three major developments which have taken place. One is the analog photogrammetry. From about 1900 to 1960, the photogrammetry was done on the photographs, aerial photographs, on the paper prints. Then 1960 to 2010, the analog photogrammetry was developed, where a lot of instrumentation helped in interpretation of the photograph, creating various kinds of maps, stereo model from the photographs. Then later on, from 2010 onwards, we had digital photogrammetry, where paper photographs were replaced by digital photographs, and the software came and the data started analyzing through the software, and elevation models were created with the help of that. So, this digital photogrammetry is a technique actually that permits us the reconstitution of the topography of the ground in our computer, and we can apply actually this digital photogrammetric data for varied application to create various kinds of maps as well as draw the contours. Then later on in the drone also, the photogrammetric techniques have been used and photographs have been taken and analyzed almost in the same fashion as we have been doing in conventional digital photogrammetry. A drone platform will consist of two hardware parts. One is the flight platform and another is the sensor part. So, if we compare this to remote sensing satellites, the most significant advantage of drone remote sensing is the flexibility of replacing various sensors. You can take the data, collect the data from different sensors and study the property and characteristics of different objects using different type of sensors, which we cannot actually do once the satellite is launched in case of remote sensing. If we see what are the advantage and disadvantage, merit, demerits of airborne images and drone based images. So, we have in airborne large coverage, whereas we have very high resolution in the drone based images. We have high resolution, but we have very high resolution, and we can get sub-millimeter accuracy from the drone based images. The timing is controlled by the provider. The image can be acquired in drone based at any time on demand basis. Susceptible to weather condition, the airborne, but it is also susceptible to weather condition. It is affected by cloud airborne survey, but it is unaffected by cloud cover because of the low height. The sensor systems which we are using in drone, they are two types of broad categories of the sensor: active sensor such as LiDAR and SAR, and passive sensor such as red, green and blue, multispectral, hyperspectral and thermal cameras. So, these are the two broad categories. The second category, which is active sensor, we will learn in the next lecture. And now if we select a particular type of passive sensor, the specific type of sensor which will be required by the drone will entirely depend upon the application in hand and the data which we are going to collect during the flight. So in this lecture we will discuss about the passive sensors. Based on the sensor systems, now drone may be broadly classified into two categories. This is the photogrammetric based and the LiDAR based. Now both type of sensors are quite different, although both provide us three-dimensional output, and the output may look similar but they are quite different from each other. In survey mission, the choice whether we should go for a photogrammetric sensor or we should go for a LiDAR drone, it depends mainly on the application which we are doing. In addition, there are certain operational factors such as cost, complexity, everything is considered while selecting these sensors. When we are talking of the photogrammetric drones, so it is photogrammetric drone is described as a photogrammetric measurement platform which operates with the remotely controlled or semi-autonomously or fully autonomously without a pilot sitting in the vehicle. Now, photogrammetric drone will capture large number of high resolution photographs. This is the advantage over traditional photogrammetry. So, we can get photographs with the sufficient overlap such that the same point on the ground is visible in the multiple photographs, and these points are used to create 3D model or mosaic of the area. So, this is how the photogrammetric drone looks like. We take the photographs, you can see a bunch of photographs which are taken together and later on they will be stitched to create a mosaic and carry out the analysis part. We create 3D models from these photographs with overlap region. So, high resolution 3D model will contain not only elevation or height information, but we can get information about the texture, about the shape, about the color of the point. So, we can do very good interpretation of the terrain from these photographs. Photogrammetric drones are cost effective and provide very good flexibility in terms of capturing either 2D images or 3D images. That is the advantage. The drone photogrammetry will offer us various new application in close range aerial domain, because we take the photographs from a low height. So, the information obtained is very detailed information, and this introduce a low cost alternative to the classical manned aerial photogrammetry when we are doing large scale topographical mapping or creating 3D maps, detailed 3D maps of the ground information. Drone images are also used in combination with the terrestrial surveying. So, that is called the data fusion. So, we have data from terrestrial surveying and we can fuse this data, merge this data along with the drone images in order to complement the data for 3D modeling and creating ortho images. We are using RGB cameras, which is the standard visual cameras here, and these visual sensors will offer us still or video data of the area which is collected in the standard visual red, green and blue wavelength part of the electromagnetic spectrum. As already mentioned in previous lecture, these RGB images can be studied either in 2D mode or we can create a 3D model again with the help of the overlap region. And these 3D models can later on be used to create either digital elevation model, digital terrain model or digital surface model, which is the basic requirement in many of the applications, and particularly when we are doing town planning or when we are working on some hydrological model. These DEMs which we generate from the high resolution commercial satellites, they are at lower accuracy as compared to the LiDAR and other sources, we create the DEM, Digital Elevation Model. The RGB cameras are standard visual sensors found on most of the drones they carry. They capture very high resolution photographic and video data similar to traditional camera. We can use them in various applications like mapping and surveying, where we can create 3D models or create the orthomosaics for topographical mapping and infrastructure inspection. We can use in the construction industry or monitoring the infrastructure like bridges, buildings and roads. It could be used in marketing and media, which is another area, capturing the promotional imagery for real estate, tourism and media industry. If we compare the two images, so on the left side is the UAV image in color, and on my right side is the satellite image, because the resolution is poor of the satellite image as compared to the UAV image. We can see much more detailed information from the UAV data. So, that is the advantage we derive from UAV photogrammetric data. We also use multispectral camera, as the name itself is suggesting. It collects the data in several spectral wavelength region, including near infrared band in addition to the RGB bands. And many applications such as crop yield estimation or crop health monitoring or crop identification, that will all require infrared images. So, these infrared images, near infrared images, which we are collecting from the multispectral camera, it is very helpful for digital image analysis. Then we also have images from hyperspectral cameras. Hyperspectral sensors will help us to identify minerals, vegetation, and they are ideal for use in the crop health, water quality and surface composition. So, we can analyze hyperspectral images for very specific applications. Now, if we compare spectral information and spatial information, which is available to us from various photogrammetric data sources, hyperspectral imaging, spectral information is very high and spatial information is very high. So, that means this particular data is very useful to us in several applications. If we say multispectral image, then spectral information is medium, but spatial information is high. So, little less useful than the hyperspectral imaging. If we look at the RGB imagery, spectral information is low and spatial information is high. So, depending upon the information content which we want to derive, whether spectral or spatial, we can make a selection of the data from sources. Then we get thermal data also from the thermal sensors, and they are capturing the differences in the radiant energy to show the temperature difference of the objects. They will capture the data in the long wave infrared area of the spectrum, which is ranging from 8 to 12 micrometer range. So, this is well beyond the visual wavelength part. So, this is the advantage of thermal sensor, that we go beyond the visual wavelength region and use this data to capture the temperature difference. Now, if we look at the key application of these photographic sensors which we are using in the drones, they are used in several applications like recreational activity or industry or agriculture and precision farming. Multispectral sensors are very useful whenever we are doing the study related to crop. Drone will help farmers in monitoring the crop health and the conditions of the soil in large area. If you want to do certain inspection and surveying of the bridges, the power line and the site safely, then the drone with the LiDAR and the vision sensor. So, it is a combination of several sensors together we use. In search and rescue missions, thermal imaging sensors will detect the heat signatures. So, they are very helpful. So, they will allow rescuers to locate missions personnel in the disaster zones. In defense and security, we can use drone integrated with the radar system, vision systems and infrared. It will make necessary for surveillance and the situational awareness. So, depending upon the application, these photographic sensors have their utility. If we look at the flow diagram when we are using photogrammetry with the drone images, then one part is the data acquisition. We acquire the data from camera, from a scanner, from digital imagery. This is one part. The second part is the procedure. We have to use certain procedure like rectification, then we create orthomosaics from them, then we use stereo plotter, analytical plotter, the soft copy workstation we can use. Then lastly the product, the output which we are going to generate from these photographic products. So, this could be orthophotographs, they could be maps in the form of the elevation model, etc. We can derive various outputs. Now, we have to follow a certain mapping procedure when we are using photogrammetric data from the drone. So, we have to design the project, do the planning in that particular area, carry out the reconnaissance survey. Then the next part, which is very important, is the flight planning of the drone. So, today we can do this flight planning with the help of various software and high resolution images, maybe the Google Earth image or maybe some other data, and we carry out certain planning. Then selection of the ground control points so that they are visible and they are used further for creating the mosaic. Then we acquire the image, aerial image acquisition is done. Then once the images are acquired, then we are doing the image processing work where we are doing georeferencing and we are creating the mosaic and removing all sorts of error which could be present in the data set. We use several software to do this activity. So, in the software we will actually give photographs as the input, then we will align photo, that means they should be geometrically registered together. Then we will import the ground control points which we had established and are seen on the photographs. Then we can create point clouds from this data, create a mesh, create the mosaic of the digital surface model can be created, and finally we can get the orthophotos which can be directly used for digitization purpose and creating the maps at different scale. This is the complete flow chart of the procedure, and in this flow chart, complete flow chart, we have several steps. And the first step is that we have to do mission planning, and under the mission planning there are actually two divisions. One is the flight parameter and another is the we have to see the availability of the devices with us, availability of the software, availability of the sensor system. So, this flight planning parameters, we will identify the area of interest, we will decide about the ground sampling distance, collect the information about the camera. Then available devices will see what are the software available and what are the drone systems which are available to us. Then the next part is the image acquisition part. In the image acquisition part, we will acquire the image, but we require some additional parameter like calibration of the camera system which we are using and the coordinates of the ground control points. So, once the image is acquired, then we can create the mosaic of the image, we can join them together to see the whole area, and then using the principle of triangulation, photo triangulation, what we used to do in photogrammetry, we will create digital terrain model or digital surface model and carry out feature extraction or 3D modeling or creating the ortho photograph. So, this is a complete flow chart of the procedure, and this is systematically followed in order to determine the various parameters from that. Then drone flight. The flight may be undertaken either in manual mode or assisted mode or completely in the autonomous mode. It will depend upon the mission specification, the platform type which we are using and what is the environmental condition at that time. We have on board GNSS and INS, which are the navigational devices. They will guide the image acquisition part. The navigation system will allow performing a flight according to the plan which we have made prior to actual flight, and communicates with the platform during the mission. The coverage per flight hour for a photogrammetric based drone is much higher, 5 times higher as compared to the LiDAR based drone. So, we can collect a very large area from these photogrammetric drone as compared to the LiDAR based drone. So, we can acquire high quality data which can be captured in less time at an overall low cost. So, our data acquisition cost from the photogrammetric drone is also lower. So, as I mentioned that we have to do flight planning as we are doing in aerial photogrammetry. So, flight planning and data acquisition mission is normally planned beforehand using the software. So, we have various software which can help us in doing the flight planning, starting from the knowledge of the area of interest, then what is the ground sampling distance and what is the intrinsic parameter of the onboard digital camera, because it has to be calibrated. The desired image scale, camera focal length, these are generally fixed in order to derive the flying height of the drone. We can compute the flying height and it should not fly more than the allowable height. The camera perspective centers are computed after deciding the longitudinal and lateral overlap which we want to keep in between the strips. All these parameters can vary according to the goal of the flight, according to the objective of the flight. For example, mission for detailed 3D model generation will usually require higher overlaps between the images if we have to create a 3D model of the area. This is a typical workflow which consists of the 4 steps here. The first step says data acquisition and generation of the raster data. So, all our digital images are in raster format. Then the second could be extraction of the vector data. So, we can create vector data from the raster data through the digitization process. The third is import and layering of the vector data and the raster data into the GIS environment, because we want to use this data along with the other data sets. And then the fourth part is analysis and decision making. So, this could be application part in different fields. Now, the procedure which we are following after acquiring the photographs from the camera, the first step in data processing software will begin with the picture insertion. That means input the picture. A structure from motion method, SFM method, will align these pictures to each other, so that now you can create the mosaic from the area. They are aligned all in the with respect to same reference systems. The bundle adjustment is then carried out from these photographs, which will allow to create 3D point cloud model. Then we will create a mesh of the triangular irregular network TIN, which will be interpreted from the point clouds for a digital surface model extraction, DSM. Some software has the possibility of ground control point for georeferencing. So, they help us in georeferencing using the coordinates of the ground control points. All these photos join together to form of the mosaic of the whole flight area you can see, and maybe you can drape this area onto DSM to produce an orthophoto, and this orthophoto can directly be used like a map. So, software will take help of the software. There are many software. Some software are useful for flight planning mission. A good drone system with the professional mission planning and post processing workflow, once the data has been taken, helps ensure that quality data is captured to get very accurate results. Good overlap images are taken because the accuracy and provide error corrections as compared to the complete reliance on the direct georeferencing method in the LiDAR system. Photogrammetric drones will generate very accurate 3D maps, fully color, high resolution information, and this provides us visual context for 3D data and make the interpretation and analysis much easier as compared to the LiDAR point cloud data, because photographically we can see the details also in that model. There are some flight planning software or apps which are available nowadays. This table actually compiles the information about them. Some of the software like Map Pilot, FlyLeechy, then this is USGS Pro, Pix4D Capture, and Drone Deploy. Operating system is given, whether it has the cloud processing capabilities, that is also mentioned, and what is the web source from where the additional information can be obtained, and various applications of this. In addition to flight planning, we can do lot more from these software. Some UAV photogrammetric mapping software which we can use for various activity, which I have shown in the flowchart. So, we have very long list, but for the guidance given some list of the software. Drone Deploy for 3D mapping, Pix4D Mapper is a photogrammetric software. Then we can use Maps Made Easy, 3DF, Jeffer, Agisoft, Precision Hawk, OpenDroneMap or ISRI Drone 2 maps for ArcGIS. So, these software are helping us in order to do processing from the photographs which we are obtained. Then there is a photogrammetric technique which is called structure from motion. So, what it does, it will use overlapping 2D image from the drone camera and will create a 3D model of the area. This particular software will compute camera orientation parameter and 3D structure of the scene. So, you will have a detailed point cloud model from this particular software. Then we are using technique which is called simultaneous localization and mapping SLAM. So, SLAM is a technique that allows a drone to build map of unknown environment while simultaneously tracking its own position with that map. So, for any unknown environment, it will create a map and continuously tracking its own position within that map itself. If we look at the accuracy without GCPs and with GCPs, so we get a very high accuracy with the help of the GCPs, particularly if we focus these areas, we find the improvement in the information when we are using ground control points for registration purpose. How do you create the images from the drone? Drone will be programmed to fly and at an elevation, at a height, and at predetermined time interval the photographs will be taken. As you can see here, photograph number 1, photograph number 2, photograph number 3, they are all taken at predetermined time interval. And these photographs have the overlap enough to create a seamless image which can be compiled. So, down below you can see that this is the compilation of the several images to create a mosaic, so that the entire area is visible for analysis carrying out the mapping. We keep the overlap between the photographs. As you can see here, 3 photographs which have the overlap, very good amount of 80% overlap, because we can see this building common in all the 3 successive drone images, and we are using the capabilities of the overlap region to create 3D model from these photographs. We can generate orthophotos, the procedure which I have explained you. So, here this shows orthophotograph of an area, and the advantage of the orthophotograph is that it is considered as a rectified photo, and we can carry out direct measurement from these photographs as we do on a topographical map. So, this is another example of the orthophoto. So, orthophoto, we actually try to remove the relief displacement and we can see the plan of various buildings. So we can compare the two orthophotos which are taken at a different time and find out what are the changes in the area which have taken place over a period of time. So this photograph also actually is depicting certain changes which have taken place in the area over a period of time. So change analysis can be carried out. We can also carry out the digitization, on-screen digitization from these orthophotos and create various kinds of thematic maps. So this image shows that the various features which are visible on the orthophoto are being digitized. Then the raw images, you have the raw images, and these raw images are to be georeferenced with the help of the GCPs, coordinate systems, and then you can create actually georeferenced model of the area. So this is the UAV raw images of a part of IIT Roorkee campus, and these are the geotagged images. Now these images with the help of the GCPs have been geotagged, and now its geometry is same as the geometry of the earth. You can actually carry out topographical mapping from these images. As you can see on the left, you can see the photograph in the background, and there are contours, height have been used to draw the contours, and from these contours now you can create digital surface model or digital terrain model, which is shown on the right side. So we can also carry out mapping and contouring, and also in this picture you can see that the crown area has also been automatically identified or marked on this map with the help of the software. We can draw the profile of the ground, or we can generate a digital surface model. As you can see here, this is a building and the line which is drawn over here. So along that particular line we would like to see what is the surface model. So the curve in the green, it will show the profile. So it's become very easy to understand the topography of the ground. If we carry out a cost comparison by a traditional land surveying approach and using the drone photogrammetric survey methods, on x axis is the size of the area in acre, and y axis is the cost which is involved in US dollar. There are two curves. One with the green here, this indicates that the cost is increasing as the area is increasing when we are doing land surveying. But the second graph here, which is in the red, it shows that there is a very small change in the cost after we increase the area. After a certain area increase, there is a small change in the cost. It is not as steep as in case of the land survey. So the cost wise, the UAV survey, drone survey becomes economical when we are doing land surveying work. We can use these images, photogrammetric images, for agricultural crop mapping, because they have been taken from the low altitude and the details, the crop conditions are very clearly seen on this high resolution photogrammetric data. Now in precision agriculture, the people have used these images to identify which particular piece of land is suitable for what kind of a crops. So depending upon the soil conditions and depending upon the irrigation facilities, that can be decided upon. One can also find out the damage. For example, the red one here is indicating the crop health. So we have sensors like hyperspectral camera or infrared regions where we can use these images to identify which particular area is actually having good crop and which particular area is having some kind of a diseased crops. For traffic management studies, these images are also very useful to us. Then drone has been used in the construction industry to monitor the construction, to monitor and to keep a track of the materials coming in and going out. So in construction industry, at several drones, as you can see here, there are several drones at different heights, and which are continuously taking the data and transmitting the data. So, in construction industry, it has been found to be very useful because it will cut down the manpower cost and will give you the real picture of the ground. Then in construction also there are some unauthorized construction. So, that unauthorized construction can also be determined. For example, you can see that there is a building at the back of the blue building which is unauthorized because the approval of this building has not been taken by the local authority. So, municipality and local bodies are using this data to find out the encroachment and to find out the unauthorized construction in the area. You can create a 3D model of any object. For example, here 3D model of the buildings on the hilltop and isolated model of the 3D building has been created, and these kind of models are also very useful if we have to carry out the retrofitting work and if something is damaged during the disaster activity. Then photogrammetry has been used for enterprise inspection. So, a physical inspection to the selected site sometimes is not possible due to the topography or due to the time involved or the distance from the headquarter. So, the drone will conduct the inspection across a large region and it will reduce the cost and increase the coverage of the area. As we can see here, the pipeline, very long pipeline which is going from one place to another. So, the drone is continuously monitoring the if there is any leakage in the pipeline or pipeline requires some maintenance repair at any place. Then in filmmaking also the drones are playing very important role and capturing those adventurous scene where it is not possible for the human being to go and capture those locations. Surveillance of the border areas continuously because the quadcopter can stay for a longer time at one place, it becomes stationary. So, this can be used to carry out the surveillance work of the vulnerable spots in the region. Then in case of a disaster, for example, in case of the earthquake, the drone images are very useful to get the real picture of the ground in order to assess the amount of damage from this. Then in case of the fire or in case of any disaster activities, again uh, in emergency services we take the images and find out how much is the damage, in what direction the fire is spreading, and we can take the appropriate measure with the help of this photogrammetric data. In flood situation also, where it is not possible to go from a low height, the drone can provide you images, photographic images, and these images can be used actually to take appropriate protection measures from the flood. So, this is the drone image where we can see the flood in the entire region, and we can find out which are the areas where the flood depth is more and which are the areas where depth is less. Drones are complementing remote sensing activities. So, we have lots of data from the satellites at different resolution. We have aeroplane based images also. So, we can actually supplement the information which we are getting from the drone photogrammetric images at a very high resolution, and we can prepare high resolution maps by clubbing the data because this is the low flight altitude data. So, this will give us very rich amount of information without any atmospheric interferences. So, the main advantages are of the drone photogrammetric images are the flexibility. We can procure the image everywhere at any given time. So, as and when required, we can send the drone and collect the data. We get very high resolution data which otherwise is not possible. And finally, the lower cost in comparison to the traditional aerial photogrammetry, we get the lower cost of data collection and data analysis part also. This particular data which we are getting from drone photogrammetry is also very useful in GIS environment. So, we can use actually this data in the GIS as a very powerful tool which can enhance the application of GIS once we give this data input and also do the integration with the other data. So, UAV photogrammetry has actually reached to its saturation when we talk about the cost, when we talk about the accuracy and speed it offers. It is preferred in many situations. Some of them are written here when we want to map the bare earth site, because if there is a vegetation cover, that will obscure the ground information. So, the areas which are not obstructed by tree and building and other object, this technique is very successful technique. When we have to create a DSM, then UAV photogrammetry is a preferred technique. Also, when cost consideration are the governing factor, when you want low cost solution, then UAV photogrammetry provides the low cost solution. So, where photogrammetric drone is useful? It is useful when cost and equipment has become a criteria. When we want the details which are visual details, which we can identify from our eye and see the details, and in many workflows such as utility inspection, construction progress tracking. So, these are the areas where we are preferring the photogrammetric drone. So, these are some of the suggested reading. Thank you very much.